Next we have relay. Relay is also a switch that connect or disconnect the two circuits, but instead of a manual operation, a relay is applied with electrical signal, which in turn connects or disconnects the another circuit. It is used for both AC and DC circuits. So here you can see the diagram of the external casing and internal structure of the relay, and here we have a detailed diagram. So in this diagram you can see this is the internal structure of the relay. Here you can see we found a copper wire on a metal core, and the two ends of the copper wire are connected to the two pins. To these pins we apply the DC voltage. When you apply DC voltage here, this coil will act as a magnet. And here we have two contacts, which is normally open contact and normally closed contact. So this is the internal structure of the relay. Let's understand the operation of a relay. Here you can see we have two contacts here, normally closed and normally open. So when a relay is not working, when it is off, it is connected to the normally closed position like this. But when you close this switch here, you can see when the switch is closed, a current will start flowing from this DC source to this coil. Now this coil and this iron part both will act as an electromagnet. So as now they have become magnet, they will attract this common terminal towards them. So when you switch on the relay, it attracts this common terminal towards the normal open position, and this relay is switched on. So in this way the relay works. And in mechanical relays, when it get connect to normally open position, it makes a sound, clicking sound. So it means relay has switched on. But this sound is not present in the electronic relays. It is only present in the mechanical relays. How to read value on a relay? So here we have three different types of relay. In the first relay, you can see here 6 volt DC is written. So this relay is for 6 volt DC operation. And in the next relay, here you can find DC 12 volt is written. So this relay is for 12 volt DC operation. And this relay also is for 12 volt DC operation. Rest of the readings are the different combination of the voltage and current. But the actual value on which this relay will work is 12 volt DC, 12 volt DC for this relay, and for this relay it is 6 volt DC. Connection of a relay in a circuit. So in this diagram you can see how to connect a relay in a circuit. So here a bulb is connected to the normally open position of the relay, and common terminal is connected to the power supply, and another wire of the power supply is connected to the bulb. So in this way we can connect our relay to the load. So when you switch on the power supply, this common terminal will go to the normally open position and it will make the circuit. So now the current will flow from this power supply to common terminal, then to normally open position, then to bulb, and from bulb to again power supply. So in this way this circuit will be complete and bulb will glow. Here is the detailed diagram of the pins of the relay. Here you can see we have 3 pins at one side and 2 pins on another side. So where we have the 3 pins, the middle one is the common terminal. The 1 and 2 are the 2 connections of the coil which we wrap around the core. So here in this diagram you can see 1 and 2 is the basically coil connections, and the left hand side of the common terminal is normally open terminal, and the right hand side terminal is a normally closed terminal. So this common terminal internally moves to these 2 contacts. As it is visible in this diagram, this common terminal moves to this contact. Testing of relay. So in this slide we will see how we can test a relay. So as you can see in this picture, this relay is in off state. It is not connected to any DC power source. So to check it, we will connect red probe to the normally open contact and black probe to the common terminal. So as you already know, when a relay is in off position, its common terminal is connected to the normally closed position. Here this common contact will be connected to the normally closed position internally, and there is no connection between the common terminal and normally open terminal. So as there is no connection, the meter should read the infinite impedance. As it is showing 1, it means it has infinite impedance. There is no connection between it. And also, as this knob, this rotating knob of the meter is set to the diode position, or we also call it buzzer position, there will be no beep sound as there is no connection. So in this way, you can check the relay whether it is a faulty one or good one with the help of this continuity test. We call it a continuity test. When your knob is set to the buzzer position, we call it continuity test. To the next terminal, you can also check in the same way. Now we have connected the red prop to the normally closed position and black to the common terminal. And as we know, there is a connection in between these two terminals. So at this time, the meter should give a beep sound. So if it is giving a beep sound, it means your relay is good one. Now you can also check it for the on position. For that, connect your relay to the DC power supply. Suppose we have a 9-volt relay, so we will connect it to the 9-volt battery. And when you connect it, and if it is a mechanical relay, it will give a clicking sound. So now check for the continuity between the common terminal and normally open position. So when relay is on, there is a connection between these two terminals, common and normal on contact. So as they are connected, now this time meter will beep. Okay, and for the other combination, common terminal, normally closed terminal, it will not beep. So if it is a good one, it will not beep. If it is a bad one, it is a faulty one, it will beep. So we need to replace that relay with a new one.